creating linear models for data, exploring line of best fit. So we're going to go back and analyze the shoe size compared to the height in inches. And what I want you to do is we're going to create a scatter plot on your calculator and use the linear regression feature to find the line of best fit. So although your calculators are in class, the program is going to do it for you. So in order to create this, they're giving you an A value, so 0.39 rounded properly is going to be your slope, and negative 16.56 is going to represent your y-intercept. And what we need to do now is we need to actually go ahead and convert this to words. So instead of y equals, that's representing your shoe size. Instead of x equals, it's representing the height in inches. So you can say that to calculate one shoe size, you would do 0.39 times height in inches minus 16.56. And here is your line of best fit, algebraically and in words. Now what we want to do is we want to go ahead and describe the correlation between height and shoe size. So do you see how the points are tightly clustered and it's rising? That indicates that there is a strong positive correlation. So now if we look at this R value here of 0.914, the R value is close to 1. So what that means is that there is a strong positive association, okay, or correlation. If we had the opposite, where the R value was close to negative 1, so up here, then it would mean that you have a negative association, okay, and a perfect one, in fact. And then lastly, if your R value is said to be close to 0, there is little to no correlation, okay, so meaning they don't kind of go together, and that's what we'll start looking at more. So looking at these scatter plots, you can see this very first one. See how it rises? I'm going to say that this has a positive correlation, which means my R value is close to 1. So your R value would be 0.87, which would be positive. Your R value for this one, see how it's decreasing, it's falling, it's negative 0.6, so it would have a negative correlation. And over here, do you see how the points are completely scattered? It appears that there is no correlation or little, so it's 0.33. It's really close to 0. So now looking at this, they give us a new line of best fit. So this trend line, 0.35x minus 14. And I want you to use it to get a prediction. You are actually going to take your prediction of 67 inches and plug it in. And I want to know, what would this person's shoe size be? So if you guys are looking at my graph, do you see how the height in inches is the x value? We are actually going to go ahead and plug in the 67 for x, and we need to go ahead and evaluate it. So what they're going to show you here is that, actually, I'm going to show you because I don't like this setup. So what I want you to see then is if my equation is 0.35x minus 14, and as I said before, that your person is 67 inches tall, I want you to plug that in for the x. And then I want you to go ahead and type this whole piece in. And what this is saying is that the correct shoe size should be 9.45, which again, give or take, someone's going to be between a 9 and a 9.5 shoe size. I would probably predict a 9.5 shoe size because you're closer to that if I rounded it up. So what we're going to do now is we are basically going to do what I just showed you, and we're going to complete a table where they plug in the information. Okay, so they give you all of these values. They give you the line of best fit, 0.39x minus 16.56, and I want you to calculate the predicted shoe size and then compare it to the actual shoe size to see how close were we. Were we off by a lot? Were we pretty close to our prediction? So you can see that all they're doing is they're taking the height, which is x, and plugging it in. So my predicted shoe size for the first one was about a 7.5, and the original, the actual, was a 6. So I was off by quite a bit, by about -1.5 sizes. Okay. So now what we want to do is we want to go ahead and keep typing in our formula, and I'm basically going ahead and I'm replacing, let me show you. What I would be doing is I would type 0.39, I would plug in x, which in this case is 70, minus 16.56. So I need to figure out what the actual predicted shoe size was, and that's going to give me 10.7. When I do the next one, I would do the same thing, 0.39. Instead of x, I'm plugging in 67 minus 16.56, and when I calculate that, it's giving me 9.6. So I went ahead and did the calculations for the next few, 4.1 and 6.1, completing the same process. Now, doing the residual or actual, it takes the actual, which in this case, the actual shoe size here is a 9, and I'm going to subtract my 10.7. So what I'm getting is a -1.7 shoe size, meaning, sorry, a -1.7 difference. So I was off by a little bit, again, a little over a shoe size and a half. The next one, the actual shoe size is an 11. My predicted shoe size, I said, was a 9.6. And then when I simplify that down, it's giving me a positive 1.4. Again, I went ahead and I completed the rest of the table for you, so you can fill this in, and you can see that we have everything typed perfectly.